I will be talking about different conceptions of risk and uncertainty, the two terms that are often used interchangeably, but it makes sense to differentiate them and to actually differentiate different layers of uncertainty that are the result of complexity of systems around us in the real world, and financial systems being the case in point. And then I will be discussing whether complex systems require complicated models to predict them and regulate them, or whether we can sometimes rely profitably on simple rules. And I will show that people, individuals, often do use simple rules to solve various problems in the real life, and that they can be used successfully to solve, to do individual financial planning. And then at the end, I will briefly present a project with Bank of England where we were looking at whether simple rules could be used for financial regulation. And otherwise, everything that I'm going to be talking about is a product of many years, hours of interdisciplinary work between cognitive scientists such as myself, economists, applied mathematicians, computer scientists, machine learning people, and biologists at both Santa Fe Institute and Max Planck Institute for Human Development in Berlin, with which I'm still affiliated. So, the bedrock of much of the modern, still, microeconomics and finance is the Homo economicus. Homo economicus can order all possible outcomes according to his preferences and choose accordingly. His choices can be modeled as urns, where each of his action is like an urn that has knowable outcomes, such as red and green balls in this situation, for which the decision maker, the Homo economicus, can estimate probabilities. So although maybe he doesn't know whether on the next draw he's going to draw a red or a green ball, he can estimate the probability with which he will draw a red or green ball from left or the right urn and then choose accordingly. So he lives in a world of risk. Work that is still the foundation of modern economic theory is based on the assumption that people know all of the available outcomes of their actions and can at least estimate the probabilities of these outcomes. So the general equilibrium theory, the portfolio allocation theories, others are based on these assumptions. Also, one of the dominant models of explaining how people make decisions, the subjective expected utility theory and its offshoots, prospect theory, cumulative prospect theory, and so on, are based on the assumption that people can enumerate all the outcomes of their actions and assign probabilities. However, more and more in cognitive science, it has been recognized that this is actually not so in many real-world situations, that rather than facing the world of risk, we are facing different layers of uncertainty. One of the recent reviews of uncertainty in cognitive science talk about things like the black swan situations, where these little urns contain maybe little bombs sometimes, but we are not sure when and what kind of bombs are going to occur. The Knightian uncertainty that I'm going to mention more in a moment, where we know the outcomes, but we cannot estimate the probabilities. The radical uncertainty, where we don't even know what kind of balls are there balls at all, and what are their probabilities. And then, of course, there are dynamic changes of probabilities over time, where either probabilities change or both the probabilities or outcomes change. Of course, this is nothing new to you, because Frank Knight already in the 1921 was discussing the difference between risks and uncertainty in economics. How many of you have heard about Knightian framework for risk and so many of you. By the way, I will encourage, if you have questions during the talk, just let me know. So I'm in Santa Fe Institute, we always interrupt each other and yell at each other, so just go ahead, you know, Michael. Knight was talking about two kinds of risks, and then the uncertainty. Risk is when probabilities can be deduced a priori. For instance, if we know that we are dealing with a fair die, we can a priori estimate what is the probability of each side falling. If we don't know, or it can be derived from the data. If we don't know whether the die is fair, we can throw it many, many times and then derive from the data what are the odds. But he was saying that in most situations, probabilities cannot be deduced or derived from the data. Recent example might be Brexit, where in advance it was really difficult to predict what are the outcomes of this big change going to be, and how can we estimate probabilities of these different outcomes. And hence, the estimates of how is the Brexit going to impact the economy were varying widely, and are still being adjusted by Bank of England over and over again. So it's really difficult to estimate this. Andrew Law from MIT and Miller are another kind of set of economists that took it a step further and differentiate between even more layers of uncertainty. So their level 1 is complete certainty, level 2 is risk without uncertainty, where both outcomes and probabilities are known. Then level 3 is fully reducible uncertainty, where outcomes are known but probabilities are unknown. Level 2 and 3 would be two variants of 90 in risk. And then we have level 4, which they claim is the most frequently encountered by all of you in the real world and financial markets and economics, where parameters vary over time. There are many complex interactions between variables that are difficult to represent in models. There are non-stationarities of probability distributions, and therefore it is difficult to use statistical laws such as central limit theorem or so on to approximate them. There are many unknowable factors that are influencing the situation. And then level 5, they call it, is irreducible uncertainty, the polite term for a state of total ignorance, which they assign to, they're like, okay, we don't even deal with this. This is for religious leaders and philosophers. So, and then they even have actually level infinite, which is a Zen uncertainty, and that's just a joke. Okay? So they really thought about, like, it's not, there are many different kinds of uncertainty. And of course, you know it. I mean, there are many sources of uncertainty in finance, because finance is a prototypical complex system. The most important, very important effects events in finance are rare, and we have a really poor understanding of causal mechanisms that lead to them. And of course, we are dealing with a complex system where many agents are embedded in networks, where, as Charlie was saying, actions of one agent affect actions of many other agents. There are many feedback effects, delayed effects. There is a strong sensitivity to initial conditions and shocks. Two otherwise similarly identical banks, one can survive and one can fail, maybe just because of their network position and so on. So all of this contributes strongly to this deep uncertainty in finance. These are just some financial bank networks, and this is a network of Austrian banks from a recent paper from a Santa Fe Institute external faculty. Of course, tipping points are also a property of such systems. And what I'm going to focus on next is that the ultimate agent of financial systems is a human being whose beliefs and strategies, decision-making are subjective and private. And it's difficult for us to know in advance how people are going to react. So next I'm going to talk about how are actually people coping with uncertainty. So uncertainty is not only present in financial systems, but in almost any daily situation we are encountering. So unlike in economics, where you have your darling theory or two, and then you all kind of agree that about some tenets, psychologists don't agree about anything. So there are many theories about how people reason, how people make decisions, and how people cope with uncertainty. So one school of thought is that people are hopelessly biased. Or maybe I'm exaggerating, but basically that people have problems in estimating probabilities, in understanding their own position among others, about estimating how confident they should be about their decisions, and that in general they have problems in making decisions. And this is basically like a bunch of little theories that explain different parts of cognition. Then there are some kind of more universal theories, such as Bayesian probability theory that has been applied to the way people make decisions, which is kind of more hopeful. And it has this, it preserves this idea that people are able to enumerate different possible outcomes of their actions, assign them probabilities, and then in some way calculate what might be the best decision. I'm going to talk about an approach that has been developed in particular at the Max Planck Institute, where I was before, and it's influenced by Herb Simon's idea of bounded rationality of agents that use simple rules and in interacting with complex environments actually produce a variety of different behaviors, and that's that people actually use a variety of different tools, rules, that are often useful but can backfire if used in wrong situations. The simple rules, their main property is that they do not use all of the information, unlike for Homo economicus, where it's always useful to for whom it's always kind of better to use all of the available information. Simple rules systematically disregard part of the information. But by doing that, they can be more robust and more complicated models because they do not rely so much on potentially erroneous, unreliable, missing data. They can be useful when applied in appropriate circumstances, and most importantly, perhaps, they're easy to teach and learn. They're easy to explain to others. Unlike maybe some more complicated, more opaque models where it's, after all, at the end, it's not clear what is causing what. Here are some examples. There are a number of different simple rules that are used in various areas of cognition. The simplest ones come from area of perception, and that's gaze heuristic. How many of you have heard about gaze heuristic? Okay, so imagine that you are playing a ball, whatever, and you need to catch the ball. So how are you going to catch it? An optimal model would be to calculate the trajectory, taking into account the ball, the speed of the ball, the speed of the wind, and then calculate where exactly the ball is going to fall, and then just go there and pick it up. But what seems that we and other animals have been doing is to use something that can be called gaze heuristic. So you fix your gaze on the ball, then you start running, and then you adjust your running speed so that the angle of gaze remains constant, so like this. So, oops, and then you catch it. It has been shown in many experiments and studies that this is what it seems that this is what people do because people do not know in advance where the ball is going to fall. They kind of run towards it, and they do not go straight to where the ball is going to fall, but they are following the ball as it's falling. And so these are some of the cues that they're actually using the gaze heuristic, and the same heuristic is used by dogs to catch frisbees. Apparently, that was the first study of this heuristic. Another is, which is familiar here, is about, I call it descent heuristic. You all remember the miracle on Hudson River, where this plane successfully landed on Hudson River because it couldn't reach LaGuardia Airport. And so how did they do that? How did they know that they're not going to be able to land on LaGuardia? They need to land on the river. The co-pilot said that he was using a heuristic that a point that you can't reach will actually rise in your windshield. A point that you are going to overfly will descend in your windshield. And so as he was seeing that the airport is descending in his windshield, he realized, I'm not going to reach it. He needs to land. So rather than, it was not a decision, at least consciously, there was a product of a number of different, integrating a number of different factors, but just basically focusing on this one cue. Other examples of simple rules, there are plenty of them in cognition, or for producing inferences about different things. Like which object is larger, where should I invest, how do I decide whether something is good or bad. One extremely simple heuristic is recognition. So imagine that you're on the show Who Wants to Be a Millionaire, or a German version, Wer wird Millionär werden? And then you ask questions such as, has more inhabitants, Detroit or Milwaukee? And so it turns out when in studies we asked American students to answer these questions, 60% were correct. But German students were much more correct. They were 90% correct. How is that possible? It is because many German students never heard about Milwaukee. And they thought, okay, I heard about Detroit. It must be a larger city. And in this case, and in many other such cases where the size of a certain object is related to the number of times it is mentioned in society or mentioned in the media, is a good cue for estimating, for choosing this object according to size. So when ignorance is systematic in this way, then it can be informative. And it has been shown that this recognition heuristic, even in some circumstances, works to choose who is going to win Wimbledon, and even some people were using it to choose which stock to invest to on stock market. And at least in the bull market period, some time ago, it worked. It does have some value when used appropriately, when used in appropriate circumstances. And this can be analyzed and mathematical and so on. Another example are fast and frugal trees. Fast and frugal trees are like decision trees, but they are fast and frugal because they do not necessarily use all sources of information, and they have exit at every step. This is an example of fast and frugal tree that was actually used, is still used in an American hospital, in an ER, where the question was, how does the doctor decide when a coronary patient comes in with what might be a heart attack, but we are not sure, whether we should assign this patient to an intensive care, which is cost more money, or normal nursing bed, where of course there is a danger for patient's health. And for a long time they were using some complicated sheet and logistic regression to decide this, or they were supposed to do it, but of course who is going to use such a complicated model in this life and death situation where you need to make decisions fast? And what they were actually intuitively using was something like this. And then Green and Mayer came into this hospital, actually formalized this rule and tested this rule and saw that it actually worked quite well. And the idea is that first you look at this the EEM, whether the ST segment is elevated. That's one part of this electroencephalomyogram. And if the segment is elevated, then immediately you put the patient to a high-risk category. If not, then you ask the second question, only then. So is there a chest pain? And then if not, then the patient goes to a low risk. Otherwise, you ask if there are any other symptoms, and then decide based on. So there's a free queue decision making. And when compared to results of this logistic regression that used many more queues and integrated them all and weighted them optimally, this fast and frugal tree actually performed better. This is this ROC curve where we have on the x-axis, we have false positives. On the y-axis, we have hit rate. And then the higher you are towards the top left corner, the better the rule performs. And this red dot is this fast and frugal tree. Okay. Any questions so far? Okay, just interrupt. So there are many other simple rules that have been noticed in the area of sociality. So that people use to decide how to treat other people, how to choose from whom to learn, with whom to cooperate or not. Tit for tat is one famous rule that may or may not be used exactly, or there are various variants of this rule where basically you'll cooperate with a person until they cooperate and so on. Equality heuristic is when parents need to decide how to split resources among children or friends, how they split their, whatever they have. Often people use equality heuristic or divide equally. So many other rules have been described in sociality and for moral decision making. Just remember the 10 Commandments and so on. So there many societies are using relatively simple rules to manage their day-to-day social life. And then, besides these kind of more general rules that can be applied in many different situations, there are also a number of domain-specific rules. So in medical decision-making, there have been described a number of rules that doctors use like this to decide which diagnosis to give to the patient, how to treat the patient, and so on. Farmers' almanacs are full of this kind of old wisdom things, so, which farmers have been using for centuries. So how to determine when to plant, what is the weather going to be tomorrow, and so on. And in financial decision making, there are actually many simple rules that are both kind of notes from old sources, since the Bible and Talmud, to the modern financial advice. And here is one rule that is often mentioned is this 1/n, which is rather than doing some optimal portfolio allocation, allocate your money equally to each of n funds. It is rumored that Harry Markowitz actually used this strategy rather than optimal portfolio allocation to plan his own retirement. And it works and it is because when you have a lot of investment options, but you have a small learning sample. So somebody estimated that to estimate really Markowitz models, you need more than 100 years of data for these different investment options, but you often don't have such long data series. And in this case, you have high uncertainty of parameters. It's really difficult to estimate them, and it might be better to just use 1/n. And a relatively recent paper by Demiguel et al. Explored when 1/n is better than its more optimal, more involved approaches. Several other rules I will mention briefly. Rule of 72, maybe you heard about that, that financial advisors sometimes teach to their customers that for a given rate of return X, an investment will double every 72 over X years. This works when the rate of return is fixed. So note, every simple rule will work in some situations and not in others. Or pay free to make free. Left in 3 years, always pay off new charges plus 3 times initial interest. This will work when interest rates are around 40%, as they are, 14-15% for credit cards. 2010 rule, limit credit card debt to 20% of annual income and credit card payments to 10% of monthly income. 48 hours rules, wait for 48 hours before you buy anything. Pay 2 times minimum, and so on. The question is now, shall we teach people these simple rules, or shall we teach them more general knowledge about finance and how to calculate, interest rates, risks, how stock markets work, and so on? What is more important? So this kind of specific financial knowledge and understanding of calculations, or these kind of simple rules, the wisdom, if you wish, of investing, of managing finances. Alan Greenspan was proponent of financial literacy education, where we would teach people how to understand better how financial markets work and how to calculate their own finances. The Bernanke statement here could be interpreted as more as a proponent of financial wisdom, where we should help people to better understand how to borrow and save wisely and how to build personal wealth to kind of be more financially satisfied. So this is interesting because those are two different approaches. So do we teach people how to calculate, or do we teach them how to use simple rules to manage their finances? And colleagues and I investigated that in the last couple of years, where we scoured Bible, Talmud, and many modern texts on financial planning to come up with several hundreds of rules that have been mentioned as an advice for people how to manage their finances. And over a series of studies, we managed to distill them to 10 rules. Okay, maybe it was 11, but we kicked out the one. It was similar to the others. Okay, but something like a very small number of rules. And they come in 3 categories. One category are rules for long-term planning, where many of these sources will suggest that people should adopt a long-term perspective, always keep some money for a rainy day, such things. Another set of rules is risk-taking. So to increase your wealth, many, since earliest days, sources advise that people should take some risk, but calculated risk as much as possible. And then the final is, and we were very surprised by this, we're thinking this was an error, but this was showing up over and over again. An important aspect of financial planning is kind of take it easy. Money is not everything. Money can't buy you happiness. And then this related to the other statement, like always give something to charity, and this kind of thing. So take a step back. So it's interesting. Okay, so those are these simple rules, and we compared who is more successful, people who are using these simple rules or people who are good in calculating. Now to judge, to have a simple test of how good are people in calculating things, we used one of these tests of numeracy. We used it in a previous research when we were investigating medical decision making. So some of these items are for diseases, but it doesn't matter. Basically, what they investigate is how good are people in estimating probabilities, just calculating very simple probability problems. And so these are not trick questions, but these are very simple questions. And we had 9 of them, and here are the 3 examples. So imagine if you flip a fair coin 1,000 times. What is your best guess about how many times the coin will come up heads? 500, 400. So we coded everything correctly between 400 and 600. But we conducted it on a nationally probabilistic sample, large 1,000 people in Germany and the US. And a quarter of people in both countries give an incorrect answer. So they don't give like 400, they give 200, 800 or something like that. So the concept of chance is not something that the general population have. Okay, and another question is this. Which of the following numbers represent the biggest risk of getting a disease? 1 in 100, 1 in 1,000, 1 in 10? And this, too, is difficult for people. They would say 1 in 1,000 because they focus on the denominator. So again, we have a quarter of people saying it incorrectly. And then this particularly heartbreaking one is, if the chance of getting a disease is 20 out of 100, what would this be in percent, right? Again, we have close to like 30% of people in both countries answering this incorrectly. Okay, so obviously it seems that we need to increase the numeracy of the general population, but the question is how will that affect their financial planning? I just want to say that those who were incorrect, it's not that they said, I don't know, or they gave some completely random answer. They knew that there was something with the numbers 20 and 100 that they should do. So 5% said 2, 12% said 5%, and then some said 50%, 80%, so there was some combination of these numbers. We also tested people's financial knowledge. So this is like numeracy, but specifically for financial problems. So calculating interest rates. Here, for instance, suppose this is taken from another study that was conducted on a large sample in the Netherlands. Suppose you had $100 in saving account and the interest rate was 2% per year. After 5 years, how much do you think you would have? More than 102, less than 102, or exactly? And so still a quarter of people get this incorrectly. And then this is a more difficult question, because a long time period, which asset normally gives the highest return? Saving accounts, bonds, or stocks, and incorrect or don't know is more than half of the Dutch population, and similar results in the US. Okay, so in a study, colleagues and I asked people in Germany and the US to answer these questions about financial literacy, so numeracy and financial knowledge, financial wisdom, and then we were looking at their objective and subjective financial well-being. So we would ask them, okay, what are your savings now, and what were your savings a year ago, and what were your savings a year ago, a year before that? And we're also controlling for the income and various measures of debts and so on. And these are the results of just regressions that include all of these variables and as controls, and then include numeracy, financial literacy, and financial wisdom. And these are the regression coefficients that we have found. So interestingly, we found that for literally none of the several financial indicators that we investigated, this knowledge how to calculate and specific knowledge about how financial markets work was not related to people's financial well-being. What was related is this agreement or following of these simple rules for planning financial markets. So basically, somebody who said, yes, I do follow the rule, always save some money for the rainy day, was better off than somebody who knew how to calculate interest rates correctly. Similar for retirement planning and for general overall financial satisfaction. The utility of simple rules versus teaching people calculation seems to be now more and more documented in experiments. This is one experiment. This is not by our group, but has been recently done by the Urban Institute. They were collaborating with a bank in Arizona, and they gave people these little messages such as this. Don't swipe for small stuff. No, don't swipe the small stuff. Use cash when it's under $20. And the sample were credit card, the people with the revolving credit card credit. I'm almost out of time. Okay, I'm almost done. And they would give them these simple rules whenever they would log into the bank, or in another group, they would send them this by email. Another group, they would send them calendars so they could put them on their fridge. And this actually had effect on their credit balance. Over several months, it decreased their credit balance for $100, but it had an effect, which is kind of interesting. Okay. And then finally, I will skim through the idea that simple rules could be used for financial regulation. This is, the broader question is, do complex worlds require complicated models and regulations? For instance, Basel 1, 2, and 3 regulations are becoming increasingly more complicated. And this is just a funny estimate by Andy Haldane, the current chief economist of Bank of England. How many Excel columns are required in quarterly bank reports to the Federal Reserve over years? And this is a slightly exponential trend, where we currently require 2,200 Excel columns starting in 2011 and so on. Okay, so do we need this complexity? And perhaps the idea was maybe not, because simple models can be more robust to limited information, less sensitive to outliers, and more transparent and easier to communicate. And one statistical reason behind it is the bias and variance trade-off. Simple rules are almost always a little bit wrong, like this left-hand side picture. They're always a little bit off target, but they have low variance. They're always off target in the same way. More complicated models that capture all of the intricacies of the training sample, of the samples on which they are trained, depending on the sample, will give always a different answer, but on average, they will be exactly right. And so depending on this trade-off, sometimes for very complex models, for high uncertainty in the parameters, variance will be so large that it's better to have a systematically biased model with lower variance, because then the overall error will be lower. Okay, that was a statistical argument, which has much more to it. But, in the collaboration with Bank of England, we were investigating several of these kind of simple rules for financial regulation. And one of them was fast and frugal trees for predicting bank failure. We were looking at whether we can predict a failure, defined in a particular way, of 116 global banks at the end of 2006. Based on my colleagues from Bank of England found a number of indicators that could be used to predict that, and usually they would be put all together in a large regression analysis. But we designed a simple fast and frugal tree, similar like to triaging patients in an emergency room. This was fast and frugal tree for bank failure, which only operated on free queues. Okay? And again, if you look in a similar way compared to the logistic regression that uses all of the queues, it was as good or better. So sometimes it's good, sometimes it's better, sometimes worse, but it's not much, so it's usually comparable. While at the same time, it is kind of simpler to explain. So you can easily explain it, and at least with a bit of judgment, one can use it for the first triage of banks and notice those banks that might be problematic. Okay, in sum, I was talking about differences between risks and different layers of uncertainty in a complex financial systems and how individual minds process this complexity. I was talking about simple rules that often can be as good or better than complex models. And I would conclude that complex flows do not necessarily require complicated models, and that simple rules can be as accurate and also faster, easier to implement, and more transparent, perhaps more importantly, to communicate. The important thing is that they need to be well designed. You cannot have just any simple rules. Simple rules that people use for centuries, all these farmers' almanacs, Bible, and these kind of things, they have been honed over centuries through trial and error. Many of them are biologically rooted. These new rules, in these new situations, we need a lot of expert judgment, people like you, to devise simple rules that are reasonable, that can work. And of course, one always needs to be sensitive on the changes in the environment, because then the effectiveness of simple rules will also change. Thank you.
Hi, Mirta. It's great to hear your talk here. One of the things that I'm really curious about, and I'm not sure if you looked into this, is where these heuristics come from, right? So the descent heuristic is great, right, that this pilot was using. But how do people figure those out? How do they enter the culture? Do you have any sense of those things?
Yeah, so some of them are maybe some almost rooted, almost evolutionary ingrained. So for instance, the gaze heuristic, other animals use gaze heuristic as well. So those are some things that might come already, we are born with them in our perceptual system. Maybe some basic social heuristics, like for instance, in times of threat, it seems that groups have this almost intuitive urge to group behind the leader and to kind of be more, to copy more others. While in times of war, when everybody's more relaxed and everybody does not have such a strong urge to coordinate in groups. So some of them can be kind of honed through evolution. Many of them could be just learned through cultural evolution, through centuries of working on a particular problem. And then parents give it to their children, they're propagating books and so on. So culturally we learn, okay, rules that work. And then some of them are constructed like this artificially. So we decided to construct this fast and frugal tree by just trial and error and seeing that they work. And so in the modern world, the situations are changing all the time. So I think we are more and more coming into the realm where we need to reinvent the rules that we are using. It doesn't, that many of the simple rules that were working before are not going to work anymore because the environment changed so much. But that does not mean that now we need to start using more complicated models, but work on developing new simple rules that work in the modern situation.